Hi, we are going to talk today about how to do mole conversions. To do that, we need to remind ourselves about some substance. So, for example, if I have calcium bromide, CaBr2, 1 mole of that substance, because that's the definition of a mole, is equal to the molar mass of that thing, of the formula mass of it, found from the periodic table of the elements. So if we go to the periodic table of the elements, and to do that, I'm going to look at the periodic table, and you can do so too. See if you can find the formula mass of CaBr2. So there's 1 calcium, 40, plus 2 bromine, 79.9, and you get 199.88 grams of calcium bromide in 1 mole. But there's another definition. If you remember last Friday, we talked about how that is also equal to 6.022 times 10 to the 23rd particles. I'm going to have to move my screen over just a wee bit here. Right? This is also equal to that many particles. And if you remember, that is Avogadro's number. That is Avogadro's number right there. And that is true for every substance. If I've got 1 mole of any substance, I have that many particles of that substance. Now, I'm going to also point out here that those particles could be atoms if it was an element. They could be molecules if it is a covalent compound. Or it could be formula units if that thing is an ionic compound. Not a covalent compound, an ionic compound. This happens to be an ionic compound. So it has Avogadro's number of formula units. So we can use this equality that we have up here to be able to convert from moles to grams, or moles to particles, or particles to grams, or particles to moles, or grams to particles. Whichever way you want to do this, we can convert back and forth between these things. To do that, what we're going to do is we're going to do a little bit of factor label. So if I ask for example problem number 1, if I ask you how many grams are in, let's go with 2.43 times 10 to the 27 particles of calcium bromide. Oh, barely squeezed that one in there on the screen. How many grams are in that many particles of calcium bromide? This is done just like stoichiometry. We're going to draw a line, and we are going to start with the number that we start with, only number from the problem, 2.43 times 10 to the 27 particles calcium bromide. We are trying to go, it asks us how many grams, so we are trying to take that answer to grams of calcium bromide. So this is all of these mole conversion problems always going to be one step. We've got particles here, so we need particles down here. We're going to put particles on the bottom so we can cancel out the particles on the top. Does that make sense? Once we've got particles, what would we like to convert to? We'd like to convert to grams of calcium bromide. Where do we get grams? Every time we are going to get grams from the periodic table of the elements. So we've already done that work. We're not going to redo it, but you could, in theory, do that again. It's 199, got to remind myself, 199.88 grams. And particles is always going to be Avogadro's number. If we had to use mole in this step, remember a 1 always goes in for moles. It doesn't ask us to use moles in this problem, so we're not going to go through moles. We don't need to make this any more steps than we absolutely have to. We used to do this in chemistry. We used to always go through moles, but there's no need to do that. No need to make your life more complicated. Now we need to plug this into the calculator. And the way that we plug this into the calculator, I'm going to bring up my document camera quick. Hopefully you can see this on the document camera here. My document camera, I'm going to focus on my calculator. This is my favorite calculator, the TI-30XA. It's the one I recommend for this class. The app needs to be updated clearly. All right. It's a little bit of washout there. If I lean over a little bit. Yeah, there we go. All right. So to plug this in, I'm going to jump back and forth a little bit here. To plug this into our calculator, we're going to start off with this 2.43. And it says times 10 to the 27, right? So I'm going to plug in times, and no, do not do that. If you plug in times and use that 10 to the x button, you're going to get the wrong answer on this problem, I guarantee it. So let me show you how to do it. 2.43 times 10 to the 27. There's one button on this calculator that does times 10 to the, and it's that button right there. Your calculator may have it as a button, or it may be like one of these graphing calculators where instead of a button, it's above the comma. And you have to hit second EE, or maybe it's above the x to the -1, and you gotta hit second EE. Or if I pull it up real quick, I can show you on my phone. I've got RealCalc, which is an app that if you're looking for an app to be able to do this, it does it pretty well. It has an EXP button. Oops, fudge. It has an EXP button. Doggone it, I did it again. EXP button. There we go. I'll keep touching that back button. EXP, right, is the same thing here. So it could be EE, it could be EXP. If you have a Casio, yours probably says EXP. All right? But that right there, so now I'm going to do it. I'm going to hit the button. EE or EXP or whatever times means times 10 to the. So when I hit EE, I'm hitting times 10 to the. All right? So if you say it like that, if you get it, you'll hit this right every time. That right there, that number plugged into this calculator correctly is 2.43 times 10 to the 27. If you plug it in this way, you'll never get it wrong. On my phone calculator, right, it's kind of cute. It does 2.43 E27. It even shows, it's hard to see that, a little times 10 to the on there to show me that it's in the correct scientific notation. All right, so we got that number plugged in. Now we multiply by the next number over, multiply by 199.88, and that's going to give me this equals, I'm just going to hit equals here to show you what number I'm getting, all right? Now we're going to take that, and you don't have to hit equals, you can just divide, okay? That's what the next thing is. I'm dividing by the next thing on the bottom. The thing on the bottom is 6.022 times 10 to the 23rd. It's Avogadro's number. It is worth memorizing. 6.022 times 10 to the is EE23. If you do this correctly, your calculator should show you this number right here, 806,000, which is kind of a large number. I expect a bit of a large number here, all right? I'm going to have my calculator convert that to scientific notation, which I do by second and psi, and it'll go like that. On these calculators, mine's out of batteries, unfortunately. If you hit mode on most graphing calculators, there'll be an option up there to go from flow to psi to ing or something like that. You want to go to psi on there, and you can do that one. This calculator has it above the DRG, the degrees, radians, or gradients a button. So you hit second, and you hit that button, and it'll let you transfer it to scientific. Now, unfortunately, every answer will be in scientific. So to get it out of scientific, you go second flow, and it'll go back. But I want it in scientific notation. As a chemistry teacher, I always accept answers in scientific notation. Your math teacher may not, all right? So remember that before you go to math class. I'm going to round this to 2 decimal places, excuse me. So I'm going to write in 8.07, that's 6 rounds up. But don't forget out here at the end, you can't just leave off this part, right? That's got to be times 10 to the 5th power. So we're going to do 8.07 times 10 to the 5th power. Before somebody points out, hey, you didn't do the gone part. Yeah, particles is on the bottom, gone. Particles is on the top, gone. All right. So that's how you work one of these problems. And every problem is going to be basically the same, only one step. Sometimes you'll have grams. Sometimes you'll have moles. Sometimes you'll have particles. Particles always gets Avogadro's number. Moles always gets a 1. The only one you're ever going to have to calculate is those grams, which you got to get off the periodic table. Good luck.